Hello, everyone. Thank you for joining, and welcome to today's webinar on adapting decisions to changing business environments. And before we get started, I'd just like to cover a few logistics. Your lines are muted for the webinar, so you'll use the chat window to ask questions. And we will leave time at the end of the presentation for a short Q&A session. If you have problems hearing or anything else, any problems with your seeing the screen or hearing, any technical issues, please let us know. So with that, let's go ahead and get started. My name is Colleen McClintock, and I'm Vice President of Products for Sparkling Logic. And also with me today is our presenter, Carlos Serrano Morales, who is Sparkling Logic's CEO. How you can adapt your decision logic to frequently changing external factors. And the types of applications that benefit from this approach are things like fraud risk management, inbound marketing, and dynamic pricing. And Carlos will be focused on fraud today. But these types of the techniques that he'll discuss and the approach using smarts and the analytics capabilities in smarts are applicable to any of the types of applications that require the ability to evolve decision logic quickly in order to keep up in order to take advantage of opportunities or keep up with threats, and basically to keep your organization competitive. So Carlos, I'll turn it over to you.
Yes, hello everybody. So let's get started. Thank you for the introduction, Colleen. So what am I going to be talking about today is essentially how we combine the insights that we can gain out of data with the expertise that we have acquired by conducting a business for many, many years into decision logic that can stop essentially fraudsters from disrupting your business, from disrupting your online transaction systems, for example. Now, the reason why we're going to be talking about this among all the possible subjects in adaptive decisions is because, first, this is a pretty big problem, as outlined in a number of studies that have been conducted over the past years. This online transaction fraud, even though its percentage out of the total number of transactions is dropping as we become better at catching them, the absolute value, the absolute amount of money lost to it is actually not dropping. It still represents, in the $3 to $4 billion range, which is not small at all, and actually not an insignificant percentage of the transactions themselves end up being involved in some sort of fraud event. So it's a little bit less than 1% for your typical online transactions from computers. It's a little bit higher, actually, on mobiles. Mobiles are more of a victim of those things now. In addition to the money lost there is efficiencies also, efficiency problems. Anytime there is a transaction, an online transaction that goes wrong or that is a candidate for being analyzed as a fraud capability, well, you have essentially people involved in looking at it. You have caseworkers, you have investigators. And it's estimated that up to 15% and even more of those transactions end up somewhere being reviewed. And, you multiply that by a few minutes per case, and you have a pretty significant impact on essentially efficiency of your business. Now, not only is it a pretty big problem, but from a decision management perspective, fraud risk has a couple of characteristics which are really interesting. So the first one is that fraud evolves all the time. The fraudsters are particularly good at imagining new ways of essentially depriving you of your money. And the consequence of all this is that you can never, up to now, but that's not going to last for long. And pretty quickly, you will see that new types of frauds will emerge that your decision logic will not have taken into account, and you will be back essentially in the trenches trying to fight it. So it's essentially an evolution all the time. The interesting part of the evolution is that it's not something you cannot really forget anything about the past either. So essentially that means that if you detect a small, a certain type of fraud trend, you cannot let it rest. You cannot say, well, it only represents 0.X% of all my fraud, so I'm gonna focus on the rest and not focus on this one. Because as soon as there is a small vulnerability in your system, it gets shared. A lot of code gets shared, etc. So at the end of the day, you are dealing with an environment, situations that change absolutely all the time, and with a willingness to drive those changes basically from your adversary. So that makes essentially dealing with fraud and creating the decision logic and managing the decision logic that's going to stop fraud a very, very challenging problem. So the key issues that you deal with when you're trying to stop this fraud is essentially the following. First, how do you identify that a given online transaction, for example, may be fraudulent before you even let it go through your system, so that you basically prevent it from happening from the very beginning? That's a pretty challenging problem, and we'll talk about that in a minute. Assuming you actually did not identify it as fraud but let it go through, and then somebody tells you, this was a fraudulent transaction, I want you to take care of it. How do you learn fast enough from what you've been told about that transaction and about the type of fraud, so that you can stop it from happening again? So basically, how do you stop a new fraud trend before it becomes too big? And how do you manage to never forget one and still remain efficient in the processing of the fraud in question? So if you can imagine that fraud changes all the time, that you have fraud coming from everywhere in this new interconnected world, you can imagine that the number of fraud patterns that you're dealing with is just growing. It's very similar to viruses in security. Essentially, they keep growing, and you need to systematically, keep track of all of them and try to do your best at stopping as much of it as you can, and with never forgetting anything. So how can you do that and yet efficiently process so that action or your online transaction essentially goes through in the milliseconds that it needs to go through? And how do you do that without losing your customers? And that's the typical compromise problem that you deal with in decisions like fraud. So essentially, the bad situation, the worst situation is this rectangle. I mean, there are two bad situations which are marked in red here. Essentially, you stop a transaction because you think it's fraudulent, but it so happens that it's not. So you're basically that drives a certain amount of non-satisfaction, satisfaction, and satisfaction in your customer base. And on the other hand, if you let a transaction go through that happens to be fraudulent, again, you incur financial risk, and you, at the same time, make your customers unhappy. So essentially, the fraud risk and writing and managing decision logic to stop fraud is an exercise in speed of identification, speed of deployment, is executing very quickly, and getting to the best compromise in the decision that you make. You're not going to be perfect, but you want to get to the best compromise possible. So how do we do that? And again, I'm taking here a relatively simplified view on how these things are to illustrate the principles. So the first thing that you absolutely need to do is that you do need to measure the quality of your decisions on a systematic basis. So this is something that the decision management community is starting to appreciate. So any piece of decision logic that you write, any piece of decision logic that you put in production, you do need to measure its quality. And measuring the quality isn't simply whether or not the decision satisfies a requirement. It's essentially how well does it satisfy the business goals that you might have. In the case of fraud, the business goals is to stop the bad transactions without essentially losing your customers. That's the essence of it. It might seem very simple in appearance, but as we saw just before, it's a compromise. It's actually a pretty difficult compromise. And if you take any decision problem, you will see that most of the time there is more than one business objective that we're trying to achieve with that decision logic. And those objectives are not always they're not always aligned. So frequently your legal compliance objectives and your risk management objectives might actually not be consistent, etc. So it's very important that you systematically measure the quality of the decision, or you do what we call decision analytics on it. Now, in order to efficiently handle the well-identified fraud, the fraud that you've identified as a pattern, most of the time we combine analytics and expert-driven rules. And one of the key reasons why we do that is that analytics actually represent an extremely powerful way of compressing knowledge. So a few models might be equivalent to thousands of rules easily. And as you're dealing with, exploding from the alert, always careful about possible fraud patterns without actually destroying your service level agreements, your SLAs. You also need to have very powerful investigation capabilities so that when somebody tells you, once a fraudulent transaction has been identified, so that you can go and try to identify the new fraud patterns and, of course, very quickly translate that into some sort of capability to stop at least that kind of fraud very, very quickly, even though it might mean a little bit more processing time in the transaction. And then finally, you might actually have multiple ways of dealing with certain types of frauds. You don't necessarily know which one is the most efficient one, given all the decision and metrics decision quality measurements that you're making. You might need to experiment. So experimental design is part of what gets done. So how does it translate into more concrete terms with respect to development and those things? So first thing, I'm going to give you a very high-level overview of a simplified fraud decision development cycle. So your goal is to develop this fraud decision logic. This fraud decision logic will always be some sort of combination of what typically is called variables or models and rules, and the combination of those three together will give you that decision logic that you're going to manage somewhere in a repository, so that you can go back to it and you can archive it, you can trace it, etc. That logic gets managed in some sort of decision management environment, into a fraud decision management environment, which typically contains a few components to it. So the first component that it will contain is essentially analytics. So essentially exploring the data that you have available to you, identify variables, create models, manage models, that kind of stuff. You will also have essentially expertise, so you have decision development capabilities, so where you're going to be taking advantage of the information that those models give you, inject your own expertise, things that you know about that business, things that you know about the way those things get done, as well as things that you know you're allowed to do in terms of compliance, as well as, of course, and going back to the point on decision quality, environments to be able to do decision simulation, decision validation. So more precisely, when you're trying to gain insights in particular, you're going to be dealing with a lot of analytical data, and that data will come from many sources. And this is an important aspect, or particular in fraud, but again, this is true in many other types of decisions. The amount of data that's becoming available these days for any of these decisions is staggeringly large and growing. So, the big data term covers that. But in particular, in things like fraud, the more you know about the environment, the more you know of the person, the more you know about the transaction and the history that person has had, and the history that person, the people connected to that person have had, et cetera, et cetera. The more you know, the better you are at identifying those nuggets of information that will enable you to better characterize the way that person is behaving. There is a whole world in there called variable identification, which is essentially the jewels or the most precious part of what happens as you are developing this kind of application. Variables are things like, for example, you identify the fact that for a given type of fraud, the fact that you've for example, that you haven't created a LinkedIn account might be an indicator, or that you have switched information on your credit card 3 times, over the last 6 weeks, and that kind of stuff. Identifying those little nuggets of information is basically what leads you to creating good variables, which are the basis of having good models and good decisions. So a lot of work going there, and the outcome of all that, of course, is that you've created models and variables. Now, models and variables inform; they don't decide. He'll combine his or her expertise together with the information that has been uncovered through that analysis, and we'll add decision logic rules as well as stitching together a complete decision based on all that information. And of course, we'll simulate and validate all that. So at the end of the day, you have those 2 roles essentially involved in creating this decision logic. The cycles through which you go and the speed at which these things happen varies. In particular, model creation, variable identification, and model creation are not fast tasks. These are tasks that require time, that require a fair amount of data too. So the cycles through which you go in order to update models tend to be relatively long. There are new technologies that allow you to do things in a more adaptive basis, but when you're talking real sophisticated models that need to encode a lot of knowledge, like what happens in fraud, the refresh times for the models are not insignificant. So that's the development part. Now, how does it get deployed? So if we follow the path of one execution here, we have an incoming transaction. The first thing that happens when we have an incoming transaction into a system like this is that essentially transaction gets enriched with information. We take out, the system takes out of a profile information relative to the transaction. This might be additional information about the sender, the receiver, additional information about the area where this is happening, all that kind of stuff. All that gets fed then to your fraud decision logic, which will render its decision, potentially update the profile, and you're done. At that point, you've essentially said this transaction is essentially fraudulent with this type of fraud, or I consider it's not fraudulent, or I do not know, and I will want a caseworker to work on it immediately as an intervention, as intervention case working, for example. Now, that's only the tip of the iceberg, because the other thing that happens, of course, is that profile needs to get updated. So the profile computation, it's always perpetually being updated. It's being updated by all sorts of asynchronous computations, rollups, aggregate networks, etc. Tons of information that comes from many, many sources, including the result of the fraud transaction identification that you've done. So you're basically dealing with an online system which is executing things synchronously with respect to a transaction coming in, as well as a large amount of things, a large amount of processing that's happening in a synchronous basis to enrich your profile. So what we call profile here and profile management can be implemented in many, many technologies. Some people use CEP type of technology for this. Complex event processing technology for this. Many people in the financial transaction payments community and company use more dedicated profile management, a bit lower level, that need to take into account a lot of dynamic aspects, lots of changes to variables, the fact that we might introduce variables that were not known before, so I actually need to go and do those queries, etc. Lots of different sources moving at different speeds, etc. So, in essence, a pretty significant piece of the story. So this gives you an idea of overall how these things get dealt with. But there are a couple of important problems, and I'm going to use. So the first one is flash fraud. If you take the development life cycle of these models that compress all the information around the fraud that you've seen in the past and that you've been able to identify. One of the problems that you are going to deal with is that, in fact, it just takes too long. It takes too long from the point where you identified. First, it takes a fair amount of time between the point where the transaction was approved and the point where you've been told or you've detected that, in fact, it was a fraud. Then it takes time. Once you've identified that, it takes time to accumulate enough data to identify properly the pattern. To the precision that's required in these models that combine so much knowledge. And then basically refreshing and deploying that can take a fair amount of time. So sometimes this is measured in months, in weeks. I mean, we're taking a fair amount of time when the fraud can become pretty intense. And you want to reduce that. And that's what typically gets done through what is called adjustments of the fraud strategy or essentially flash fraud management. In other words. So let me give you an example using smarts. So I'm going to skip this setup slide. I'm not going to talk too much about it, but in essence, the idea being that as you're keeping track of the information and keeping track of those transactions that have been marked as being fraudulent, you can use smarts and its BluePen capability together with its ability to go and reach data from many different sources in order to let both the data person and the expert person, those two roles, collaborate and identify very quickly flash fraud rules or flash fraud decision logic that you can then deploy in your system. Let me show you that. So I'm going to switch screens here for a second. Just go back here. Okay, so this is Smarts. Smarts is a full-blown decision management system. If you're interested in more details about Smarts, at the end of the webinar, there will be a few links that you can in order to get additional information, or you can contact us and we can give you demos or walk you through the product. I am going to focus on its usage with respect to flash fraud, so I'm going to go relatively quickly in terms of the product itself. So the first thing I'm going to do is that I'm going to assume that I have a template basically to deal with flash fraud types of problems. So I'm going to take that template. So Smarts has the notion of templates. You can create decisions that you package together in a template that becomes reusable. And I am going to simply drag and drop it to the system and ask the system to create, basically, based on that particular template, a decision for me to get started to writing those rules. Now, because I am creating a flash fraud decision, which is going to be based on analyzing data, I need data. So typically here, you would be connecting to data warehouses or that kind of system. For the sake of this demo, I'm just going to use a few CSV files. And again, in typical analytics world, you are going to be careful dissociating testing data from the data that you use to identify the fraud. So you want to isolate those things so that you're not introducing bias in what you're doing. So let me just give Smarts both a testing data set. So I'm using the evaluation version here, as you say. I'm going to give it a training data set too. Training data set is basically the one I'm going to use to discover this fraud decision logic. So let me, for the moment, get rid of this and go back to my system, and let's look at the decision. So it's connecting, it's loading all the decision, and you see a fair amount of information presenting on the screen. So let me guide you quickly around what this is. So the first thing that you can see is that on the left I have what's called the document group. So I have around 4,000 and something. Document, this is my training that usually in these things you use much larger numbers. Again, for the sake of the demo, we have it pretty restricted, and these documents have a structure that Smart inferred basically based on its content that contains all that information that I'm going to be using to decide upon. So in that information, you can see I have general information. For example, what's the account that was sending, and what's the account that received, and what's the amount that was actually involved in the transaction in question. And I'm looking here at the first transaction out of the 4,000. I have information on the sender, where the sender comes from, the age of the account that this is being sent from, receiver information, etc. And I have profiling information. So this is the enriched information that we talked about before. And in this profile information here, I have a ton of indicators. And I have indicators with respect to exchanges through checks or through credit card and things like that, and risk statistics that I might have gathered, etc. All this profile information is typically the type of variables that you will have been working on asynchronously. I will have basically created for the purposes of those profiles. Information like the number of times you've changed your credit card over the last 6 months, or the age of your account, or the number of other accounts that might be tied to the same email address, and all that kind of information. So I have all that data. In addition to that, I have this little section called fraud, and in this little section that's called fraud, there is something called identified fraud type, for which you see the chart here on the right. The identified fraud type is essentially the information that comes out of my overall process that tells me whether this transaction that I saw was actually non-fraudulent, which is the case 0, or is fraudulent with a certain type of fraud. And as you can see actually the numbers, so you have a little bit less than 100, you have around 170, 180 bad transactions or fraudulent transactions out of 4,000. So those rates are not surprising. You're really dealing in the few percentages. So the signal, in general terms, is pretty low. So that's all good. It's just data. And the first thing that the template gives me, and these are again things that you set up in the product itself, is a few metrics. And these metrics, here I have only 5, 6. There can be many more of them. And these are 3 typical metrics that you would have in fraud, in online fraud. You have your catch rate, which is essentially how many of the bad guys do you actually get, according to the logic that you already have. The hit rate, which is among all the ones that you say are bad, how many are actually bad. And then decline rates, how many transactions, percentage of transactions that you actually stop. So your goal there, and in a very simplistic view here, the goal is to maximize the catch rate without, having a good hit rate, not too bad a hit rate, and a low decline rate as much as possible. So here I'm dealing with only 3 of these aggregate metrics. You can imagine that the people in this field use many. You can see, by the way, that the rules as they're defined, so the template came with a number of default detection rules, that those default detection rules are not that good. They're giving me a catch rate which is pretty low, a good hit rate, and a relatively good decline rate, but the catch rate is really bad. And not surprising, comes out of a template. They're just there for illustration purposes. So my goal at this point is to use the system to try to uncover these better rules. So in Smart, we have an additional module called BluePen, which enables us to do that. So let me switch to BluePen. So when I switch to BluePen, my presentation, as you can see, changes. So I now I go into a presentation which is more familiar to people who deal with data. And in particular on the data side, I now have a tabular presentation of all the relevant fields, all the fields that exist, if you want, in that record. So the records, typically here I probably have 100 or so fields, or even less. Sometimes 300, 400, 500 are not uncommon. Exercise I want to do here. What I'm trying to do is to define logic that will predict the value of this identified fraud type that have been given to me. I created a field in my form called predicted fraud type. It has values right now because there is already logic that is executing. And so my goal is essentially to write logic or to find logic that will give me a predictive fraud type which is equal or as close as possible to the identified fraud type. Now because we are dealing with analytics, we need to be careful what we mean by equal or close enough. In analytics, there is an overall problem called overfitting, which is you've certainly heard of, which is when you are writing rules against a bunch of examples, or when you are creating or training a model against a bunch of examples, you actually don't want the rules to be too close to the examples. You want them to be more general than what you're seeing, so they can be applicable to things that are not exactly the data that you trained on. So there is a whole number of statistical methods to guarantee that. So in general terms, the expectation is that it's not going to be exactly the same as what's in the training set, but on the other hand, that against many, many different data sets, my KPIs, those catch rate, hit rates, etc., will behave properly. So the first thing I will do here is that I will work to try to do that a little bit of that exploratory data analysis that I mentioned. So the purpose here is not to replace tools that do that explicitly. The purpose here is to do it quickly. It's the flash forward story. So my goal here is to do essentially what the analytics people will take a few weeks doing. I need to do it in one day maximum. So I'm going to trade a little bit of precision. I'm going to trade that kind of stuff for time to decision, if you want. So the first thing I'm going to do, for the sake of going fast here, I'm just going to upload a configuration I already have. I'm going to take. I am going to select a few variables. So, for example, here I am selecting a few of the models that I have here, and I am going to say that I am going to use them to predict. This is what the target here means, to predict the identified fraud type, and I'm going to put the result of that in my predicted fraud type here. Because let me just trigger the computation. Because the signal here is so low, I am going to essentially boost it, and I have here a particular capability in Smart that allows me to boost the signal so that the algorithms give me results that are a little bit easier for me to understand. And when I did this recomputation here, what I got is a certain measure of correlation. So I can see here that a few of these variables that I have here are actually have a pretty high Gini gain. So this Gini gain is one way of measuring correlation. There are many measures of correlation possible, and then I have unique and distinct values for the field, which give me a sense for whether the field should even be considered as a candidate for this type of exercise. I can do a little bit more exploration by diving into the details of any of these variables. I can look at a little bit of its statistical distribution and its statistical characteristics, and I can even look at some of the correlation between the field in question, in this case the FAST-AT01, against the identified fraud type. And actually, I can see that there is distribution, and I can see in particular ranges of values for the AT01 that are likely to be involved in decision logic. So this takes a little bit of time. You're going to go through the variables and identify candidate variables. Now, in Smarts, I can automate a fair amount of that. So I switch perspective here, and I could technically trigger jobs that allow me to identify those predictors. So I could blindly select a very large number of variables here and click on this Identify Predictor, tap here, and trigger the identification of predictors. These are pretty heavy-duty processes that take some amount of time, so I am not going to cover them here. In general terms, this is an area where you combine expertise with analytics. So the experts are the ones who know or have an idea of which are the good candidate variables, at least to get started, and we'll narrow the selection to those, and you will start working with that kind of data. In SMART, you can do a number of other things. You notice that some of these fields here are continuous. All these scores here are actually continuous, or might be continuous, or have too many values. You can discretize. SMART gives you a number of algorithms, including supervised algorithms, to discretize values, so that when you generate the decision logic, you're doing it against buckets, values in buckets, as opposed to fine-grained values. That tends to give you more robustness in the end. It gives you a little bit less overfitting, makes the algorithms also more efficient. I'm not going to do any of that right now. What I'm going to do is that I'm going to just very quickly go and generate the rules. So to generate rules in SMART, I have a number of algorithms. I'm not going to go through the details of them, but let me just call these new rules and generate the rule set. So what I'm asking SMART to do here is to take the data, this training data that I have, and the variables that I identified, or those fields that I identified as being candidates for the decision logic, and the target that I identified, and I am asking SMART find rules that actually give me that. As you can see here, it took a few seconds to do it. I identified around 30 rules, gives me some statistics information on it, and if I click on this button here, I can get the full view with all the statistic information. I'm going to jump directly into just getting those rules into SMART to do the rules engineering or the rules analysis in SMART itself. So I will insert the rules here, and as the rules were inserted here, I can come back to SMART, and let me just collapse here so I can show you. You can see that my new rules were added. They're here, in addition to these guys. And actually, if I expand, you can see that I see them here. You have a bunch of rules in here. Now, SMART presents rules in many possible ways. So I can actually take a look. As you can see, I can keep them in rules format. I can convert them to tables or represent them in table or a tree view or a graph view. Graphs are quite interesting actually when you're dealing with fraud, because one of the things that graphs allow you to do is to understand how you get to a given possible conclusion. So let's say, for example, I'm interested in knowing how it is that I get to value number 2, for example, to my fraud type number 2, and now SMART basically builds here the decision graph that gives me that information. It tells me what it is that led to that particular conclusion. So I can see that, for example, one possible path is if my segmented VSN, 1 is less than this value, and the model, this one is equal to this value, I get to this. So essentially, it allows me to understand the possible path to get to a particular conclusion, which might be important as you are trying to understand the decision logic that was generated and to exert your own knowledge onto it, to correct it, to modify it. And all of this is modifiable. I can come here and make modifications here. For example, here there is a crisp value that I might not want. I can click on this particular button here and start modifying the values. And when the values are modified, it's just we are actually modifying the rule. So in essence, in SMART, any of these representations is something that you can use to continue the work of engineering the rules. But more important than that, for the purposes of this, is that now I have a new set of rules, and the thing I can do. Let me just snapshot the baseline. So I have my current baseline performance, and I'm going to ask the system to execute. So I should do this against test data as opposed to training data, which I can easily do by switching data here. But for the sake of going quickly in this demo, I'm going to do it directly on the training data. And you can see that my new, and I can compare now the results of my new set of rules with the previous one. And as you can see, there is, I am predicting a little bit less of non-fraud. I am becoming significantly more serious about the fraud of type number 1 in here. And in particular, you can see that my catch rate and my hit rate suddenly went up. So my hit rate went slightly down, my catch rate went up, and actually I can compare them. Let me just go to the aggregate tab and just show you. So I can see that my catch rate went from 25% on my baseline to 81%, pretty high. My hit rate didn't deteriorate too much, and my decline rate probably went up. Yeah, so I'm declining significantly more because, of course, I'm detecting significantly more fraud than before. So basically, the rules that I just generated are better candidates than what I had before. And what I can start doing now is trying to identify, looking at those rules and see whether these are rules that I really want to deploy or not. So let me show you a few features in Smart that will help me doing that. So the first feature is that I know immediately by just looking at the rules which ones are firing frequently or not. So in Smart, the little bubble here on the left will tell you whether the rule fired or not for the current document that you're looking at. So for example, this one, which is, this document sent from this account to this account for this amount. And the bar in Rule 15, for example, is pretty likely that it plays a significant role, whereas Rule 13, just rule firing rate. That might not be enough because you might actually have a rule that doesn't fire that frequently but actually contributes a lot to a given metric. So what you really would like to know is how much do they contribute to the metrics that you are following. And that's what the Rule Metrics tab here in the product allows you to do. So let me just clean up a little bit this path here. And you can see that, and I'm actually going to only focus on this last run because that's the only thing I'm interested in. There, boom. So I can look at the catch rate, for example, on a per rule contribution basis. So let me just sort it. And you can see that, for example, Rule 15, not surprising, contributes a fair amount to my catch rate. And interestingly enough, so that's Rule 14, Rule 8, which is up there, etc. So you can see basically the contributions that individual rules make to the different metrics. You can see that on the catch rate. I can see that also, of course, on the hit rate. You can see that the contributions that each one of these guys makes to those KPIs. So now I'm in a position where, as I am making modifications to these rules that the data identified, I can systematically make these executions either against the data that I have loaded in the system or through a simulation which will give me exactly the same reports against any set of data. And again, millions and millions of records if I wanted to. We have a MapReduce environment to do that. In the back end, then I get those numbers, and this allows me to with a fair amount of safety, if you want, and guidance, engineer down this rule to the minimum set of rules that is relevant for this type of goal, which is these flash fraud rules. So if you take an online system, your goal is to get to this as quickly as possible, put them in production as quickly as possible, and put as few of them in production as possible. So I have 30 rules here. I would like to reduce it down to, let's say, 10, or reduce it down to 5 rules. So what I'm going to be doing is essentially using these metrics, manipulating the rules, using these metrics in order to narrow it down to the 5 that I want, that I can then put in production. So cycles that would otherwise take a long time in an integrated tool like Smart with its BluePen capability basically takes significantly less time, and you can get to fraud value pretty quickly. So let me go back a little bit to the presentation, and then so the consequence of all that at the end of the day is that you end up with an execution picture which will look like this. essentially you will have additional flash fraud rules that will be overlaid on top of the rest that will take care of the fraud that your models haven't yet been able to catch. Next time you deploy models, you can start removing those flash fraud rules, or you can migrate a subset of them into the permanent rules. So, and you might have many of those. As you can imagine, at any point in time, I can have, 3, 4, 5, 6, 7, dozens and dozens of these packets of rules in production. So the idea that you need to minimize them in numbers and still get the best compromise, that's where it's extremely, extremely relevant. So that's fraud decision execution. Let me go back to another type of problem, which is experimenting. So you might not have a clear initial opinion on whether a new detection is actually better than an old one. You might not have enough data to decide right now. So all that I described before assume that you had some amount of data. So, I used 4,000 records there to generate a prediction. That's really not realistic in a real situation. You are going to be dealing with hundreds of thousands of records, most likely. So if you come up with decision logic to stop that fraud or to identify that fraud that you're not sure about, you might want to actually do experimentations. And you can do experimentations by simulating against the past, which is what SMARTS allows you to do, as I showed you a few minutes ago. But you can also create actual experiments and deploy them. So this is typically called champion-challenger in the financial services world. It's called A/B testing and many other words, many other names elsewhere. But essentially the idea is that you're going to deploy both at the same time, and when you deploy both at the same time, you're going to be measuring the performance of one against the other. And if at the end of a certain amount of time the challenger actually performs better than the champion, you remove the champion and replace it by you remove the champion and replace it by the challenger. That's essentially what that is. So that's and it basically amounts to some sort of semi-manual optimization. So you're not being adaptive in the sense that you're not accumulating decision quality information through time and making the decision in a semi-manual fashion. And the whole goal essentially is this. So you basically you are somewhere in terms of the quality in a valley, and you want to improve the performance of your detection. You can create essentially challenges that unfortunately might go down in quality, but of course you can create some that will go up in quality. So in general terms, you're going to have a number of challenges for a given champion, and you're going to monitor their performance through time and pick the right one. So I am not going to do a demo because of time here. We do have a webinar already recorded that talks about SMART's capability with respect to Champion Challenger. It's built into the product, so there's no setup, nothing complicated that you need to go through, and it gives you another very powerful tool to deal with essentially adapting to changing conditions around. Then a last point on adaptive decision logic. So there are out there a number of approaches to allow you to adapt your models to changing conditions in the external world. There are a number of technologies out there. Now, SMARTS provides a couple of them. In particular, SMARTS provides support for the CVFDTs, the very fast decision trees that adapt through time. However, in terms of its adoption, these are pretty new technologies, in particular in fraud risk management, because of a number of issues, and one of the key issues is the evolution without. There are two key issues. First, identifying that the transaction that you let go through is actually fraudulent takes time. It involves, in general, somebody complaining. So that goes against the ability to have these models evolve quickly. And the second one is that they also need to not forget about the past, and doing that efficiently with things like these evolving models, these adaptive models, is actually not that simple. but there is work in that area, and Smarts support some of those adaptive technologies built in also in the product. I want to conclude here. I want to emphasize the fact that even though I talked exclusively about online fraud transaction here, this here is a pretty generic pattern that you can see almost everywhere. So essentially you have a business event that gets triggered. That business event we get enriched into your system by a that then gets passed to your decision logic and then renders a decision. And that context that you are going to be providing for that business event when it comes in, it's going to be computed asynchronously for many, many different sources and many, many different types of events. And you can see that kind of pattern appear wherever you have lots of points of interactions and with your customers and lots of customers, or lots of users, or lots of potential sources of events. So we see that in wellness programs, we see that in incentive management and various types of high-touch marketing opportunities. So same approaches. So I think that I'm just going to go quickly on the key features that are required in order for you to do all this. Are essentially this: you need to be able to do decision analytics. You need to have the ability to create your own APIs. And essentially, if you have them available from get-go, perfect. You need to be able to combine analytics and expertise, the ability to adapt to data, to tap into different data sources and have your data models basically adapt very quickly without losing too much in terms of the investment that you've done. And then finally, the ability to manage and execute experiments. All those are absolutely essential for you to be able to create decisions that are going to be able to adapt through times. I think there's a bit time left, Colleen, for questions.
Okay, so if you do have a question, you can go ahead and type it into the chat window now, and we'll just take a few minutes for Q&A. So I'll give you a couple of minutes to enter the question into the chat window. Any questions that are entered that we don't have time to answer today, we'll absolutely get back to you. So feel free to enter any questions that you have now. Okay, so it looks like we do have a couple of questions. The first one is the BluePen module of Smarts included by default? And the answer is that the BluePen module is an optional component of Smarts, and this is because the analytics capability is applicable to the types of decisions that we talked about today, like fraud detection, things that need to adapt very quickly, and allows you to use the predictive analytics capability to induce rules from data, or to also explore and better understand your data in order to refine your rules. So it's not a key part of the product. It's a key part of the product, but it's for specific types of problems, and it's not included by default.
All those KPIs that I show, the ability to define KPIs for your decision, and the ability to look at those KPIs both in aggregate as well as the level of rules, all that is in the default product on the other hand.
Yes, absolutely. Thank you, Carlos. A second question is, how does BluePen compete with product offerings like SAS?
Yeah, so it doesn't. So the goal, Smarts provides a fairly limited, fairly focused set of algorithms or capabilities from the analytical perspective, which are all geared towards getting to results fast in a way that can be engineered after they've been identified. So, for example, we do not provide in BluePen itself mechanisms to create neural nets and things like that. So the goal here is really get to decision logic that you can engineer fast. So the expectation is that the heavy-duty work that goes into identifying the low-level variables and refining those very precise models is done in tools that are devoted to that, like SAS, like SPSS, and Project R, and that kind of data combination, and that you use Smarts to do the quick part. Smarts does support, I didn't mention that, but you probably saw it as I was going through the screens. It supports PMML inputs, so to the extent that those tools can generate PMML representations of the models, Smarts can digest them and basically take advantage of them in its execution. But the development of those models then still gets done in the external tools.
Okay, thanks very much, Carlos. So I think that's all time we have for questions today. And I'd just like to thank you for coming and let you know that if you'd like to learn more about smarts, please visit our website where you can ask for a free smarts evaluation. We would also invite you to read our blog to keep up with some of the latest topics in decision management. You can also subscribe to our newsletter, and of course, we'd love to have you attend one of our future webinars. And you can sign up for those on the events section of our website. So thank you very much for coming today, and we hope to see you at a future webinar. If you would like just a demo of smarts, also feel free to contact us. So thank you so much. Thank you, Carlos.
Thank you.